Okay, so we're going to talk about different horizontal and oblique or those slanted asymptotes. So we're going to take a look at some of these rational functions and just check and see when am I ever going to get a certain type of asymptote when it's not vertical. So if we take a look, our fraction, our little rational, we're only going to compare the exponent of the degree of the function and compare these two numbers here. So in other words, I'm going to take a look at what is my degree of this top function, and it looks like inside this little spot I have a 1. I look at my highest exponent here, and I also see that this one is a 2. So when my numerator exponent is less than my denominator exponent, then that horizontal asymptote is always going to be at the x-axis or where y equals 0. Now, what happens if I have n and it's the same? So in other words, my highest exponent is 2, and my highest exponent here is also 2. So if they're the same, what it's going to be y equals a divided by b. So what that means is I have to, from those terms, find the coefficient of each one. And it looks like this one's going to be that invisible one here. So basically it's going to be 5, or this a, over b. So that means my y, my horizontal asymptote, will be at 5 over 1. Or simply y would then equal just 5. So that's where my asymptote for this particular function would be. Now, if I have it where my numerator exponent is greater than my denominator exponent, so then that means there is no horizontal asymptote, and there's only an oblique asymptote, which is also going to just mean a slanted asymptote. So in order to find this, you do have to do a little process here. So we'll talk about that right now. So in order to find that oblique one, basically we're using an old school that we did before, and that is our nice little synthetic. You can either use synthetic division if you can, or in other words, your long division. So for sake of time, let's do synthetic. So I'm going to take a look at my terms. I have my -3. It looks like I'm missing a 0 for the x, and then my constant. So I'm going to go ahead and set my long division problem. So -3, 0, and then a +2. Make sure it's over my remainder box. Then I take this, x minus 1 equals 0. So add 1 to both sides. So therefore x would equal a +1. So I'm going to put my +1 here. So let's go ahead and do our synthetic division. Now, synthetic division, I don't need the remainder for this, but I just need the equation that I get in this little section to figure out what the equation of the slant is. So let's go ahead and start. -3. 1 times -3, I'll bring that as a -3 up here. Go ahead and do this calculation. 0 minus 3, that's also -3. 1 times another -3, and I put it here, so what happens is 2 minus 3, well, that would be a -1. Now, all we want to look at and focus on is just the equation part here. I don't care too much about the remainder. This is just to help me get that slant. So that means my slant asymptote here would have to be y equals -3x minus 3. So that means that's where my line is going to exist. So in other words, if I take a look at my graph and just clear that, just make it easier. 1. So it is -3x squared plus 2. And then x minus 1 on my denominator, x minus 1, and then graph. So if you notice, it's basically looks like it's coming down in this general direction and it's going to cross at this part. So if I go ahead and just pair it up with that equation, that -3x minus 3, let's go ahead and see where that slant or that oblique asymptote is. And if you notice, that line runs nice across it here, and basically this line is approaching this red line, so that's where our asymptote is going to be. And if you want to see that other bottom portion, we can go ahead and zoom out, move this down a little bit, and you notice that line goes nice and down this little section where it splits it in half. And that's our slant oblique, and that's how we use our synthetic or long division to figure out what that equation is.